we go. What's different about this problem? It does not start at 0, it starts at 2. That creates a challenge for us. Anybody know what the width of n rectangles would be? How'd you get that? Very good, 3 over n. What x values do we then evaluate the sum? Good, 2 plus 3i over n. That's a little bit different, isn't it? So, the definite integral is going to be from 2 to 5 of 4 plus 2x minus 1/2 x squared. That's equal to the limit as n goes to infinity of what? Sum from equals 1 to of Jazz has it. Good. There it is. Jazz has it. You got the 4. You got the 2 times the x sub I minus 1/2 times the x sub I squared. And then we have our width, which is 3 over n on the outside. Again, that width of 3 over n is going to have to multiply everything. If we've got 1 minute to try to clean this up a little bit, I'm going to make sure that we take our time because this could get ugly. Everybody agreed? Okay, so we have the limit as n goes to infinity of the sum from I equals 1 to n of 4 plus 4 plus 6i over n minus 1/2 times. I'm going to FOIL this out because a lot of people made that mistake earlier. What am I going to get to start off with? It's going to be a 12i over n because you have to take 2 plus 3i over n times 2 plus 3i over n plus that 9i squared over n squared times 3 over n. We'll pick up there and we'll remind everybody where we got that when you come back. Okay? Eat a parenthesis in there. Go get some brain food. Okay, there we go. So all I did is I FOILed this out. That's where people got confused the other hour. 2 plus 3i over n. A lot of people just went 4 plus 9a squared over n squared. You have to FOIL that out. Everybody see that? 2 plus 3i over n times 2 plus 3i over n. That's how you get the 12i over n in the middle. Okay? Now I'm going to distribute the 1/2 through. Limit as n goes to infinity. The sum, I equals 1 to n of 8 plus 6i over n minus 2 minus 6i over n minus 9i squared over 2n squared all times 3 over n. What do you notice? Okay, we're fortunate, all right, that as you look at the problem from the very beginning, you can see you have 3 terms, right? So you're thinking we're going to have 3 different sums that we're going to substitute. In this case, the I term goes away because you have the positive 6i and the negative 6i. Get rid of them. We have the limit as n goes to infinity of the sum from I equals 1 to n of, what'd you say? Times 3 over n, 18 over n. So the 2 and the 8 are gone. Minus 27i squared over 2n cubed. What? Eight minus 2 is times 3 over n. All right, now we're good. Now we can substitute a couple pieces and then find the limit. Limit is n goes to infinity of I'm gonna write this as 1 over n times the sum from I equals 1 to n of 18. Now you don't have to put the 18 there. You could have put the 18 out front and left a 1 there. It doesn't matter. You're going to come up with the same result. But just for effect, I'm going to leave the 18 there. Everybody okay with that? Minus, what do I take out of the next part? Good. Sum from I equals 1 to n of I squared. So this is the key part where I've now isolated this beast, and I've isolated this beast, and I need to substitute something in there. We know exactly what we do. Limit as n goes to infinity, 1 over n times what? 18n. Minus 27 over 2n cubed. What goes in there? I didn't have the heart to say anything. Okay. Limit as n goes to infinity. Oh. What do I get here? 18 minus. I'm going to get a 2n cubed, right? Times 27 will be a 54n cubed. Minus 81n squared minus 27n all over 6n cubed. We're almost there. What do we take out? (81 over n, 27 over n squared). Oh, thank you. Good job, B. Rody. All right. I missed the 12. You have the star quality of awesomeness. Okay, so we get 18 minus 54 over 12. Both are divisible by 6, right? It'll be 9 halves. Or 36 halves minus 9 halves. 27 halves, which is 13.5. Wonder if that's correct. What are the chances that we... I'm sure we made a mistake somewhere, didn't we? Well, if B. Rody wanted to call me, I would have made a mistake there. And so I go from, what? We're going from 2 to 5? Boom! Sweet.